Welcome back. In this video, we are going to talk about the limitations of binary, okay? So what limitations does binary have? We have to understand them because, yeah, that will be just a part of your exams. So the first one, okay, you have to just understand that in real world, we just use analog data, and analog data is like a wave. It is continuous, okay, it's not broken. So in every millisecond, or even if you just break it smaller than milliseconds, you will have just data there. It has infinite variations between every two different data. There are just infinite number of variations, okay, or different types of sound or color or things like that, okay? And like the natural world, there are no gaps between the values. And in computers, we just use billions of on and off switches because they only have two states. So they are discrete and finite. So you have to just know these two words, okay? Because you will have to use exactly these words for your exam. Discrete, it means separated, and finite, it means just, yeah, we have just a limited number of or limited different types of data. So binary cannot perfectly replicate continuity. It can only approximate it. We are forcing an infinite wave into a finite grid. So that is just the main thing that we are doing in changing to binary. So see, we have gotten the universal law of computing. So in binary, we know that for n bits, we can have 2 to the power of n different unique patterns, okay? If you have got only 1 bit, so that is 2 to the power of 1, which is 2. So we have just gotten 2 different patterns, which is 0 or 1. If we have gotten 8 bits, so that is 2 to the power of 8, which is 256. Okay, so we can store 256 different patterns in 8 bits. Okay, and if our n is 16, so 2 to the power of 16, we can just have 65,536 different patterns. Okay, if we just increase n, this number will just grow much larger, but again it is finite, okay? So we can have limited variations of data here. So if a question asks for the number of a variable color or values of x bits, always write down the 2 to the power of x calculation to secure your methodology marks, okay? So that is an exam tip. Then see here in sound, okay, what do we have? Fidelity, that means how similar your sound is to the actual or original sound. So here we have gotten sampling. Sampling, as we discussed before, it means taking measurements of sound wave at regular fixed intervals. Take a sample here, then just after take a sample here, take a sample here. Okay, so we after fixed intervals will just take samples. That is sampling. Okay, sample rate, which is calculated in hertz, that is the number of samples taken per second. And we know that the lower rate is equal to wider steps, missing more analog details. Okay, so if we just take lesser number of samples per second, we will lose some data there. Okay, so we'll just miss more on analog details. Then bit depth. What is bit depth? The bits used to encode the volume amplitude of each sample. In each sample, how many bits do we use? So if we are just using 8 bits, we can have 256 volume gradations, okay? If you are using 24 bits, we can have 16.7 million gradations, okay? Although just a lot, but again, that is limited. And fidelity, how accurately the digital copy matches the original analog source. You have to know this word because you will have to just use them in your exam. Then the cost of audio fidelity, it means how near it will just be to the original sound, okay? The cost is in storage, okay? So in a CD quality, where our sample rate is 44,100 hertz, which is 44.1 kilohertz, okay? And the bit depth there is 16 bits. But in hi-fi or in Blu-ray, sample rate is 96,000 hertz, which is 96 kilohertz. So that is just a lot more than this, okay? And the bit depth is 24 bits. So you can have just a lot more variations of sound, okay? So the trade-off is increasing frequency and resolution improves audio quality or the fidelity, okay? But it massively increases file size. So how you will just simply count the file size in audios, that is sample rate multiplied by bit depth multiplied by duration in seconds multiplied by channels. How many channels do you have? Okay, so that is very important and you have to just understand that. Then the next limitations that we are going to talk about is the images. Okay, so we know what resolution is. Okay, resolution is measured in pixels per inch. If an image is enlarged without enough resolution, the finite grid becomes visible and we will have pixelation, okay, as here. And what is color depth? Bits per pixel. Each pixel is stored in how many bits? So we know if we have just a lot of pixels, and for each pixel if we just take more bits, our quality will be just quite high. Okay, so bits per pixel. One bit allows only two colors. 24 bits provides 8 bits per RGB channel, enabling 16.7 million true color variations. Okay, and here again, we have gotten the same thing. If you just add or if you increase the number of pixels or you increase the number of bit depth, the file size will just increase a lot. Okay. So again, we have gotten limited. We can just increase it a lot, but it will be limited. Then after that, the text, again, okay, the number of bits per character determines how many different characters can you just use. Okay, for example, in ASCII that uses 7 bits, we can have only 128 patterns, okay, which is enough for basic English characters and control symbols, but we will have just problem for symbols or characters other than that. Then Unicode uses 16 or 32 bits. So this is created to overcome ASCII's limitation, standardizing 140,000 plus characters for all world languages. And the limitation to represent a global character set, more bits per character are required, resulting in a heavier storage penalty for every text file. So the size of your file will increase. Okay, and the grand trade-off in audio, we know sample rate and bit depth, they just create the quality. Increasing them will just increase the file size, decreasing them will decrease the file size. In images, resolution and color depth are effective on the quality of the image, and they will just increase the file size, and if we just decrease them, the file size will decrease. Okay, and for characters as well, we have just character sets. ASCII uses lesser number of bits per character and Unicode uses more. Okay, so we have just gotten that. So across every medium, pushing the digital approximation closer to analog reality demands a geometric explosion in file size. So higher fidelity requires more bits require more storage. So I hope you have just understood that very well. Then let's talk about numbers, okay, the strict boundaries of math. So in IGCSE, mostly we use 8-bit registers, but computers can just use more than that, okay, 16 or 32 bits or 64 bits, okay. But again, that is limited, okay. We can just go out of the boundaries, okay. So binary patterns are stored in registers of fixed length. There is no extra space. So the problem is, okay, if your number is just more than the range of the register, then you will just lose some bits, which will result in wrong answer. Okay, so the integer range, an 8-bit register can only hold unsigned integers from 0 up to 255, which is 256 different numbers. Okay, and in signed numbers, yeah, that is just negative 128 up to positive 127. Okay, so what happens if a calculation hits 256 in 8-bit registers? So simply we will lose some bits, which will just result in wrong number, okay, incorrect output. And that is just the overflow error. Okay, the overflow error, for example, yeah, we add these two numbers, it will be just, we will have just something more than the 8 bits. Okay, so the ninth bit will be ignored and it will be just deleted. So that is the overflow error. Occurs when an operation produces a result requiring more bits than the computer's register can physically hold. What is the consequence? The computer loses the most significant bit, causing inaccurate result, program crashes, or catastrophic failures. For these problems, okay, we can just have a lot of real world examples, but one which is just kind of very important and very famous, that is the Ariane 5 disaster of NASA. Okay, so in 1996 the Ariane 5 space rocket exploded just 40 seconds after launch. Why? A software error attempted to cram a 64-bit floating point number into 16-bit signed integer. As a result, the software lost many of the bits. Okay, and as a result, an overflow error, the guidance system failed, the rocket flipped, and $500 million was lost because of unhandled finite boundary. So when you are creating softwares, you will have to just be careful about this overflow error. And precision loss. Okay, so before this we were just performing some shiftings, okay, for divisions. So if we just shift right and any one is lost, what happens is we will just lose the precision. Okay, for example, 7 divided by 2, which is just one shift, we will have 3.5, but in shifting this one is completely lost. So what we will have 3, that 0.5 will be lost. So shifting binary patterns can drop bits off the end, leading to highly imprecise results in calculations. So if you want to be very precise about your results, yeah, shifting is just not a very good method. Okay, or at least you'll have to just do some extra things there. And some tips for your exam. The first one, vocabularies are very important. Okay, always use the word fidelity for audio accuracy, not just quality. Always use discrete for digital data, not just jumpy or separate. You have to just use discrete, okay, separated forms. And always use plain text and ciphertext for encryption. You have to just know them. Then prefix trap. Okay, we just know the difference between kilo and kb. We have just discussed about them in previous videos. Okay, kilo is in decimal and kb is in binary. Okay, in decimal that is 1000, in binary kb is just 1024. Okay, so you have to just know them. And unit conversions. Audio sample rate in kilohertz must be multiplied by 1000 to convert to hertz before doing file size calculations. And also, okay, minutes must change to seconds, so be careful about that. The no calculator rule for your exam. Okay, examiners don't want a final number in Edexcel. In Cambridge IGCSE, yeah, they want. Okay, so they want to see your logic string. A 1-minute mono recording at CD quality, which is 41.1 kilohertz and 16 bits. Calculate size in bytes. So that is the question. Pause the video, try to solve this question, then come back to see your result. Good. Let's check your answer. So the first one, step 1, convert the units. Okay, so we have gotten 44.1 kilohertz, change it to hertz. So multiplied by 1000, that will be 44,100 hertz. Then a 1 minute has to be changed to seconds. So 1 minute is equal to 60 seconds. Then step 2, write the top line bits. Okay, so that is 44,100 multiplied by 16, which is our bit depth, multiplied by 60 seconds, and it is mono, so we have 1 channel. Okay, if it was stereo, then yeah, it would be 2. Then because we want to just simply convert it into bytes, write the division to get bytes. So divide this all by 8. So the final result will be 44,100 multiplied by 16 multiplied by 60 multiplied by 1 divided by 8. And you have to just remember, okay, in Edexcel you have to just leave the math exactly like this, okay. You can just calculate if you are just sure, but you do not need to just attempt long divisions, okay. But in Cambridge, yeah, you need to just perform that. So only in Edexcel, in Cambridge, do your final calculations. Knowledge check, some questions. Once again, for each one of these questions, try to write your answers before reading the answers in the video, okay? So the first question, explain one reason why an analog signal is never fully reproducible. Pause the video and write your answer. So analog signal is never fully reproducible, okay? Then why digital uses snapshots at fixed intervals? Data between snapshots is lost. So analog is continuous and digital is discrete. And the lost data is not recoverable. Question number 2, define fidelity. Good. Let's see, have you just written it? Let's see, have you gotten it correct or not? So fidelity is how accurately a digital copy matches the original analog source. Good. Next question. Name the error when a result is too large for the register. Let's see if you have thought it correctly. That is overflow error. Good. And the next one. What are two effects of increasing sampling resolution? 1. Higher fidelity or accuracy and larger file size. And that's it. Wish you all the best. Good luck and goodbye.